Hi, I'm Daniel. I'm a software engineer in FC's infrastructure team. And I want to tell you a little bit today about the whole stack of monitoring tools we use and a little bit about how we use it. If you don't know Etsy, we are the world's handmade marketplace. We bring people together to buy and sell handmade goods and connect people through those goods. A little bit about stats so that you know kind of with how much grain of salt you have to take everything I'm saying up here. We have over 25 million members. We have over 18 million items listed on the site. We have around like 60 million monthly visitors and about like 1.5 billion page views per month. We also run a single monolithic PHP application. It's your like regular LAMP stack. There's Linux, Apache, Memcache. We have master sharded MySQL as the database. When I say monolithic, that's usually the main Etsy.com site. We still have services which are the search side of things because it's all Java and crazy, so that's not in the main application. And also the image serving stuff we have is not in the main PHP application. And as you might know, we really like deploying, and we deploy a lot during the day. How often we deploy is actually not that important. The important question is really, how comfortable are you deploying a critical change right now? So raise your hand if you could just pull up your laptop and deploy right now. See, that's amazing, because you want to be able to have fast feedback loops. You want to be able to deploy things really quickly. And the actual number doesn't matter that much as long as it fits your development workflow, as long as it fits the way you want to run your application and the way you want to work. And for us, that means when you start Etsy on your first day, you deploy the site. You don't do paperwork, you don't do anything else. You log in, you get your GitHub login, we run GitHub Enterprise on site. You get your picture taken. We have a little photo box on one of our floors where you get your picture taken. You make the change on the team site, and you deploy Etsy on your first day. And for that, we use a tool we awesomely call Deploynator. So it's our one-button deployment system. On your first click, it gets you to staging, and you can manually still check if you broke something or not, if the thing you actually wanted to put up there works. And on the second click, you're on production. And you have this awesome set of dashboards you have to look at after to figure out if the site's still up. Did you just prevent everybody from logging in? Did you just prevent everybody from buying stuff? And to let you know how we actually do that, I'll talk a little bit about the background and the stack of monitoring we're using. For system level metrics, we run Ganglia. We basically have an instance per data center or environment, which means we have, for all the developer machines that run in the developer environment, we have a Ganglia instance. We actually have two per environment, so when one goes down, the other one can still be used, and we can flip over to that. Across all the Ganglia instances, we have around 220,000 RD files, which are mostly system-level metrics. So the rough guideline here is just, if it's something that relates to the actual node, it goes into Ganglia. So Apache requests on the web server are on there, opcode cache sizes, PHP time is on there for the web servers, as much as Gearman queue, so we use Gearman for background processing. Everything that relates to a single node you can find in Ganglia. And we have a lot of scripts that run, usually on a cron, so we have one very generic cron on each box that just calls every script that's called gmetric-something in a special location, and it just collects stats we use in Ganglia. It's also fully configured through Chef, so each Chef role we have has a set of attributes that describes where the node lives in the Ganglia cluster and which cluster the node is part of. And you get awesome rainbow graphs for that. So for example, we have on our dashboards those stack graphs as for Apache requests, for example. So you can very quickly see if one of the nodes serves more or less traffic, if something's up. You can see if a node uses more memory, and it's just a very nice way of aggregating stats across a whole set of boxes. We also run statsd. Scott, I actually wanted to talk to you about the events you do, because we right now do about like 20,000 metrics to statsd, because we sample heavily on the client side. So for busy keys, we actually only send 10% of the actual values, because we found that the Node.js application, so we still use the Node.js application we wrote for statsd, and it kind of falls over at like 40,000 metrics a second, which is fine for now, because with the sampling setup we have and how we use it, it works for now. But one of our projects this year is definitely figuring out what the future for us for statsd will be. Do we want to have a different implementation? Does sampling still work? Do we want to have a different setup? How should the future look like? And we mainly use Graphite as the backend for that, and it mostly also gets traffic from our 70 web front-end service and the 24 API service we have. And we, of course, also monitor statsd because we want to know what it's doing. As I said, 20,000 is around the number of packets we push to it right now. We graph packet receive errors, so we often have the case that after a deploy, someone adds a new statsd namespace, and it suddenly the traffic to statsd goes up because it's not sampled properly. It's taking more traffic than the developer thought it would. So we also graph the packet receive errors on there, which are taken directly from the box, from the NIC, to figure out, is statsd right now dropping packets or not? How much traffic do we do? And statsd gives you a report of the top n keys that it has, and we put that on a dashboard. Actually, that's not true. We don't have it on a dashboard yet, but we have a report you can see. So whenever we have a spike on there and see that statsd is not really happy right now, we can pull up the list of top keys right now in there and then figure out what should be sampled more. And speaking about Graphite, so Graphite for us means application level metrics. We don't usually have system level stuff in there. Everything that's in Graphite is usually related to the application. We have two boxes, each have 96 gigs of RAM, 20 cores, 7 terabytes of SSDs in there. Because running Graphite on SSD makes you really happy because it's fast. We add about 500,000 metrics per minute on there, and we recently scaled it up because we had problems with the setup we had. We have basically a master-master setup where only one master is actually live. And we used to run one relay and one cache on the boxes. And the relay on the box just relays to itself and the other box. And we switched to basically a functionally sharded setup where we now have, I think, 7 relays running on each box. And one relay takes generic traffic. So there's still port 2003 running on there. You can send stats to there, and it's fine. It's going to end up in Graphite. But we also have a relay running on a different port that only takes statsd metrics. We have a relay running on there that only takes metrics from the search side. We have a relay running on there that only takes metrics from our chef runs, and then relays all the metrics to caches that only take that namespace on the box itself and the other box. That means that when we see a namespace blow up, we can directly see it on the relay or in the cache where the metrics come in. And it's also very easy to figure out what's going on in there. And the big upside of us having Graphite and Ganglia means that we can actually monitor Graphite with Ganglia. So everything that's node-specific, as I said, is in Ganglia. It means metrics that relate to how Graphite does on the box are in Ganglia. What you can see here is the traffic graph, which actually means that most of our traffic that comes to Graphite is statsd, and all those three, the green, the red, and the blue stacked graph lines are actually statsd generic traffic, statsd counters, and statsd timers. And in addition to that, we also graph and ganglia the disk writes, and a lot of metrics about the health of graphite. Because it turns out if you're having graphite problems and you're trying to debug graphite with graphite because your graphs are in graphite but graphite is down, it's kind of hard to figure out, like, blindly, where are my metrics and how do I figure out how this thing is still working. That was a big problem we had when we ran the previous setup where we didn't have ganglia script set up for it. So right now, with the new setup, we can actually look into ganglia and see, oh, that's actually interesting. It's that one cache is not writing to disk anymore, so what's happening? And there's also a pro tip in there, which is upgrade graphite. We had a problem where one of the caches was really, really slow, and we were like figuring out what is it doing, and we actually S-traced the process, and it was basically spending most of its time shell execing to make dir, which was just to create metrics, which was a thing that was in a release, I think, 2 years ago, and we actually didn't upgrade to a newer one in the last 2 years. And the upgrade fixed it, so yeah, running the newest version where the bugs are actually fixed is a good idea. Yeah, so that's mainly our graphing setup, ganglia for system level, graphite for application level metrics. Next up is logging. So for logging, we use syslog-ng. We send everything to a single syslog instance, or a central syslog instance. We write 1.2 gigabytes per minute. And it's also one of the things that are heavily based on chef rows. So each chef row has the patterns in there, has the setup and the ruling for syslog in there, so the node knows where it should send, which of its log files it should send, and which of the stuff it should send where. And it turns out rule ordering in syslog-ng, we wrote a whole blog post about that, is also really important. Because if you're running a web application, then chances are a lot of your logs are actually coming from the web service. And then, as you would do, you put your rules into web.conf, which turns out syslog-ng actually parses last. So the grow of your actual rules get applied last if you have it in a file that starts with something at the end of the alphabet. So we profiled that and actually reordered the rules so web stuff matches first, which gave us a lot of headroom when it comes to syslog traffic. And on the syslog box is also running a web front end. So after you deploy Etsy, you also go to the site we call supergrab, which is basically a Node.js web front end for tail-f log pipe grab something. And it is a really easy way for a developer after the deploy to figure out, are the error logs blowing up? Are the PHP logs blowing up? Are the info logs blowing up? Do we have problems in the Gearman side of things? Do we have problems in the web side of things? Yeah, does the site still work? It's basically the easiest way, because as fun as it sounds to actually SSH into the logging box and tail a log file, it's not actually practical after you just click that button on the deploy to, oh, let me remember to SSH into that box and actually do that thing. So we have this log stream, and there's also a version of that which we call super top, which rolls up all the lines. So the problem with that is, imagine you're breaking your main database connection and suddenly all the Apache workers are really, really unhappy because they can't talk to the database. So you get a million lines flying by in that supergrab thing, and it's not really helpful to see them flying by and see, yes, I see, something is broken, awesome, but what is it? So we have a different version of that, which we call super top, which basically rolls all of them up. And also on the logging box, we run logster, cron once per minute, which maintains state on a log file and reads it and extracts metrics from there. So we extract stuff like PHP execution time, memory, all of that kind of stuff we can't get from the plugins. And we use Apache. If you know, like, Apache Node is a very awesome thing to like write stuff into your log files, and we extract those with Logster. It's a Python thing, it's open source on GitHub, and it runs once per minute and gives us a lot more metrics. And in addition to that, we also have Splunk, which indexes all of our log files. So you know something's happening and you want to know how long has this been going on? Is there something in the past of log files? Because supergrep basically only gives you the last minute-ish of data, which is good enough for deploys, but if you want to go back and figure out something over a longer time range, we have Splunk for that. It has really easy search for patterns. It has interesting safe searches, so the stats top key stuff I talked about is actually a safe search in Splunk, where you can just click on it and see the top keys. And it's very, very powerful. And we figured out we kinda only use it as like a glorified grep through our log lines. So we have recently started to experiment with Logstash to figure out, is this something that Logstash can do better for us? Is that something we can set up differently so we can take advantage of other things that Logstash gives us? And we also don't have a good logging setup in dev right now. So everybody at Etsy has their own VM where they develop the code for Etsy Web. It runs the Etsy Web stack in a slimmed down version. It runs the same cookbooks that production does. But we don't have a really good logging setup on there, so that is also something we want to figure out right now. Is Logstash the thing we want to run on the VMs to give developers more insights into how their code is doing while they're actually developing it on the VM? And in addition to that, we also have a thing called Eventinator. I know. Naming things is only a solved problem in German, and we have this tendency to just add inator to stuff we think is useful. So Eventinator is a really awesome tool that I think started during a hack week we had 2 years ago. It tracks all the changes and all the things going on in the infrastructure. So Chef runs add all their data in there. When we change a cookbook in Chef, there is a record of that in Eventinator. DNS changes, network changes are in there. All the deploys are recorded in there. And also if we provision or decommission service, that is an event in Eventinator. Interesting point about that is we are all running on, we're running completely on physical hardware. So that's a thing where we provision service. We don't you just click on a button and the cloud does a server thing for us. Yeah, and over the last 2 years, we collected roughly 12 million events in there. And it was all a single MySQL table. It was a small Sinatra front end, and it got really, really slow. So last Hack Week, which was actually last week, we rewrote it to be backed by Elasticsearch, because it turns out Elasticsearch can do search really well across a lot of documents. And we changed the front end from Ruby to PHP, because PHP is what we know. And we now have those awesome deploy lines where in the Graphite thing, you can hover over the line and you get the diff in GitHub, a link to the diff in GitHub of the stuff that actually went out, and a link to the run log in the deployment system. So you can actually see, oh, hey, there's a spike. So let me hover over that line and see what change actually went out, and is that what could have caused or contributed at least to the problem we're having. And on the other upside, I now also have an opinion about JSON as a query language. So if you want to talk about that, that's something. We configure all of those things with Chef. So literally everything at Etsy is chefed. We use the same cookbooks in production and development. Every node runs Chef every 10 minutes. And we have a ton of plugins and handlers to actually get more insight into how the Chef setup works for us. One of that means that we use KnifeSpork for a workflow, and whenever someone changes a cookbook in IRC, we get a notification someone uploaded the, in that case, Apache cookbook, and promoted it to the development and the production environment. And that also kicks off a Jenkins job to figure out, did the changes that are on the Chef server actually make it to Git? Because in the Chef world, there's, if you have your stuff in Git and you push to the Chef server, there could be this disconnect where the Chef server has one view of the world, whereas Git has the other view. And we also are very meticulous about converging nodes. So As you can see here, this is the example output of chef run on a web node. And here you can see the chef run took 20 seconds on a converged node. That means 120 recipes on that node were actually checked against, does it still do the thing we think it does? And it does. So Chef's pretty awesome if you actually take care of it and make sure your recipes converge. That is actually making sure the node is in that state. And then we love running Chef every 10 minutes because it just gives us such a quick feedback loop and such a quick turnaround time on making changes on the Chef side of things. And we also have a handler that just tells us in IRC when Chef nodes fail to run. So we can look into it, it's just the output of the Chef run. So we can click on it, figure out which resource broke, was that recently changed, what could be the reason for it breaking. And speaking of monitoring, raise your hand if you have strong feelings about Nagios. Raise your other hand if it's love. Come on. It doesn't actually matter because it turns out computers don't care about your emotions. If Nagios doesn't work for you, throw it out, that's fine. But it turns out it works really well for us. We have 2 instances in each data center or environment. It's fully Chef generated. We have service checks in Git as well as the contacts. For the ops on call rotation, we send notifications directly to phones with like the email to SMS gateway you get from your provider. And roughly 75% of the Nagios checks actually go to the ops on call rotation. We use PagerDuty for scheduling rotations, so there's always an email address someone can send to when they need help to reach the ops on call person. And we use Nagdash to actually aggregate all the view of all the Nagios instances we have on a single web page. Maybe you can see here, so we monitor 1,500 nodes in a handful of Nagios instances. We have like 20,000 service checks, and Nagdash is our view of the world when it comes to Nagios. We also wrote a lot of tooling around making it accessible from IRC. You can see the status in IRC. You can actually downtime nodes in IRC. And one of the problems we had was that Nagios deploy actually meant making a change in Git, going to the box, Git pulling on the repo, restarting Nagios, and then making sure you actually restarted it on the right node and it doesn't need to be restarted on another node. And then we thought, if we just had a good way to deploy software. So at that point, we looked at the web stack and thought, hey, we have this awesome thing where you can send your patch off to Jenkins and it will run your patch against the tests on the CI cluster. And we wrote the same thing for Nagios. So now when you make a check for Nagios, you run try Nagios. It sends the patch off to the CI cluster. The CI cluster generates all the hosts, runs nag check config, which is a wrapper around the config check in Nagios, and tells you if it actually works or not. And turns out we already have a deploy solution, so we also have a stack in Deploynator that runs the tests, builds up all the host files, rsyncs them over to all the instances, and then restarts Nagios on the instances where there were actually changes. And this is already a really nice setup. I really enjoy working with that because it feels very natural because it's the same way as we work on the web stack. And there's also one more thing where we thought Nagios could be a little bit better because usually when you get paged, what you're lacking is context of what this means. You get this text message and it says a number, and if you're good, it sends a unit and something about it being bad or good. And there are usually like 5 things you do when you get a page for a thing. You know it's about a web node, so you check different status on there, and you already have your phone in your hand. And although I kind of think email should be plain text, all the email clients on the phones have great HTML rendering in there. So we wrote a Nagios notification handler called Nagios Herald, which basically gives you this view with an alert. It means disk space. Everybody loves disk space alerts, so in that case, you can see, hey, it's 100% full, so you get this red bar and this like tiny thing because numbers are hard. And it actually gives you a visual representation of what's happening. And you can see in the ganglia graph that gets attached, oh, this is very recent. It's not just, hey, I'm tickling the threshold here. Do you want to wake up? It's really like we're filling up the disk. And you get information about what are the actual thresholds on the alert. You get the output of df to figure out which partition is actually running low on disk space. And you also get a Splunk search in there, which tells you, hey, this alert went off 2 times in the last 7 days in that case. So within the minute of waking up, grabbing your phone, looking on your phone, you actually have way more context about what this alert means and how it relates to the past, basically. And this is already pretty awesome in terms of Nagios setup. And this is the reality of what helped us a lot, making the on-call experience a lot better. But we actually didn't stop there because we wanted to have it even better. So we want to figure out how can we improve on-call. So we have this thing called Ops Weekly. We have weekly ops rotations. So every Friday when you go off the on-call, you fill out this thing in Ops Weekly, where it actually pulls in all the Nagios alerts from that week, and you just annotate, okay, this was actually not actionable, this was because someone didn't set downtime, this was for something else, and then when we talk about the on-call in the ops meeting, we have actually stats about what's going on, and what was actually the main problem in the on-call, how do critical warning relates to each other, how do actionable and non-actionable alerts relate to each other. And there's a bonus thing where you can opt into wearing a Jawbone or a Fitbit, and it actually tells you how many of your pages you got while you were asleep, how long it took you to actually get back to sleep. And we regularly have discussions about, okay, is this something that really should wake up a person? It kept you up like 5 times during the week, and it took you 20 minutes to get back to sleep, and we could have fixed that 5 hours later and it would be fine. So it's something where we now have data about how we're doing on the on-call and how we can make it better. And yeah, so in conclusion, we use a set of tools we know, of tools that we trust, and we enhance them where they don't actually do 100% of the things we want them to do. We try out a lot of new things to figure out where new technologies, where new things could fit into the infrastructure. And we write tools around them to make them work for us where we think it's lacking. And we continuously try to monitor everything, even our monitoring, to figure out, do we actually do the best we can? And then we adapt the tools to what we want them to do. And this was really only the whirlwind tour of how we do monitoring. We have a lot more talks we have a lot more stuff on our blog. We have a lot more talks on the etsy.com Code's Craft site. We have a very busy GitHub page where you can check out a lot of our tools. We're hiring if you want to figure out the present and future of Etsy monitoring with us. And I think we have a couple of minutes for questions. So ask me now. If you don't get to your question or you don't feel comfortable asking a question from the audience, find me later and I'm happy to tell you everything about it. Thanks.
How are you guys feeling about Kale? Are you guys still working on it? Or?
It's a great question. So the question is how we feel about Kale. It's still in experiments. So if you don't know, Kale is our anomaly detection stack. And it's still in experiment status for us because we haven't really figured out where it fits into the workflow of how we monitor things and how we do it. We recently broke it with the Graphite upgrade because it didn't support multiple relays. So we are working on fixing that and trying to figure out where it fits in our stack. But we still have it, we're still using it, we're still working on it. Yeah.
How self-service is Nagios within your monitoring stack? And do you provide any tools to facilitate creating new services and checks instead of like doing like raw XML configuration or like Nagios QL or?
So the question is how self-service is the Nagios setup, and the truth is it's actually not that. So you still have to write the scripts you want to have executed, you still have to write the configuration. But every team has their designated ops person they can ask, like, hey, I want to check this in Nagios, can you help me? And everybody on ops is really excited to help people figure out how to write checks, which then maybe even go to the developer and not the ops team. Yeah?
You mentioned a little bit about wanting to look into using Logstash. I'm wondering if you can elaborate on that. What exactly you think it will replace, with your current log handling, or what other pieces, like, Elasticsearch, Kibana, whatever you might use with it?
So the question is if I can elaborate on Logstash and the possible future of it. Right now it's very much experimentation, and we have a Logstash and Elasticsearch cluster set up with Kibana. We're running it side by side with Splunk. We're trying to figure out if we have stuff in Splunk that actually would work much better in Logstash. And the big thing for us is the development setup, so giving developers a great environment on their VMs to figure out what their code is doing. So those are the main points, basically, we're looking into right now. Yeah, in front.
Are you running a single syslog server, or are you trying to split the data up?
We're running two. I now have to think. I think they just both get the same data, and we just switch over if one fails. I think that's the current setup. I'm not 100% sure. If you want to talk to me later, I can try to find out. Awesome. Thank you for listening to me.